Hi, Alvaro.
Hey, hello.
Great to see you again, man.
Indeed. How's everything? Is this link okay and everything okay now?
Yeah. Everything is great.
All right.
You coming to Vegas this year?
I am.
That's good. That's
And
good.
you are too, as far as I know, right?
Yeah, yes. I'm getting ready.
Very
I'm still
good.
kind of anxious about that, but we'll see.
Why so?
I don't know. I mean, this whole thing about Corona is just making you questioning: is it really necessary or not to travel? But still,
Yeah.
I mean, we need to have some passion at least about something, to die for something.
Well, I'm taking some. I mean, not risks. I just believe it's reasonably safe. So now I have a 2-year-old kid. So 2 months old kid.
Oh yeah, man. Oof.
Yeah.
So what's the feeling?
No, it's pretty good. It's obviously, everybody tells you like what's an experience and everything, and you never realize until you're there. Now I'm starting.
Yeah.
It's hard times. It's very difficult from a time perspective, but it's wonderful. I'm really enjoying this time. Hard, but really enjoyable. So.
Yeah, that's completely new topic in your life. Yeah. Crazy. I don't know. It's probably totally different. I don't know. I mean, being responsible for something, really responsible. It's not like a database is down or something. You just have no excuses, and you cannot blame anyone. And
Yeah.
that's really different. So Alvaro, I had a chance to test the Postgres.
Okay.
So I'm going to show some. I mean, I just tried to install everything, and it worked. So
Cool.
in my first attempt, it just worked. So yeah, I mean, it's just like going back in time.
In what sense?
I don't know, like after so many years using some managed solutions, like for the last 2-3 years, I just moved out of like doing everything by myself, and I had like this feeling that, oh my God, I need to learn again so many things, and like with the kid, like you need to learn. I mean, no one can tell you. You have to experience that.
Well, one of our goals, but we can discuss this.
Yeah, we will.
Just my recommendation, but asking about this, my recommendation is to follow the tutorial. Our docs need a lot of improvement, but the tutorial is more or less polished. It's my best recommendation right now. Follow the tutorial from start to end, and you'll learn a lot, and you will get to do some advanced stuff. Not super advanced, but like not the most advanced capabilities, but at least you'll get a good glimpse of it.
Yeah, I'll definitely will go into details with this. I'm just saying hi to Daniel Živkovic from Toronto. Hi, Daniel. I hope you are coming to Vegas this year. So
excellent.
He's running a serverless Toronto, but yeah, he says he's not coming. But we need to do some things together. The same thing. COVID is just like kind of. Making smart people scary. Feel scared, so it's just like we are scary and scared, so so it's hard. So we need to really stay safe. So Alvaro, I made some like preparations for you, and I've read everything you did like in the last couple of months inside the community and against the community and for the community. So we'll talk about that too. And I really want to hear from your perspective. I know I read the documents and what was on the net, but I really want to hear from you. What's your feeling about that community stuff? And yeah, we'll start with this tech, and then at the end we'll just spend like a couple of minutes discussing that, because whatever we do now is open source, and both you and I, we really push as much as we can open source. I know that. I mean, so it's important to have a clear understanding in the community where we're going, how we're using things, and to make everyone happy. And because it's so easy to make someone feel bad in the community, especially in open source community. So yeah, so we need to really be kind and gentle. So that's hard.
No, let me just make a small comment there. Of course, we'll get into this in details whenever you want. I may be wrong, but I think nothing that I personally or through the foundation, or definitely not my company, have done is done against the community.
Yeah, of course. I'm just joking, but
no, but it's interesting because what we definitely have is different opinions, and looks like this is a community that is not very welcoming to difference of opinions. It's like very focused on one opinion, and we are diverging, and I think that should be fine, but we'll get there.
Yeah, of course. I mean, even topics that we will discuss today in technical terms just open so many questions. Again, it's not that we have like a final decision on what tech is the best one, and then the final tech at the end of the road. There's no such thing. So yeah, I mean, whatever we do is going to open another discussion, and that's fine. That's perfect, and that's why I called you. So I know that you're going to give me some honest answers about things that you use, and
always. Yeah.
Maybe things that you don't use, but you feel them, So I've noticed your conversation with some guys from PlanetScale about the release of the solution for it's of course based on MySQL because it's using Vitess, and it's something very similar to things we'll discuss today. But people should not just stick to one technology like Postgres and forget about what other people are doing and other stacks are doing. So it's really good to have a perspective that maybe someone did something better, or some tooling which is advanced tooling. And
actually, Goran, let me say that this is one of my main thoughts about Postgres and Postgres community in general. That in general, and of course there are fantastic exceptions, but in general, the Postgres community is, I consider it, and I may be totally wrong. Everything that I'm going to say here, I may be totally wrong. So it's all my opinion. Take it with a grain of salt. But I believe, after being part of the Postgres community for around 15 years, I believe, I can say that I consider it a very inwards looking. Very few people are checking what all the database technologies are doing, what users are asking for, what enterprises are asking for, and there's a lot to learn from all the databases and all the technologies. Postgres is by far not perfect. It's fantastic, but it's by far not perfect. And I think this is a very important exercise that significant part of the community is missing. I'm trying to do my best to learn from any other technologies. And as you mentioned there, this discussion with PlanetScale yesterday was very enlightening. It was a fantastic, it was the perfect example of a technical discussion that works, where there's exchange of arguments and both parties left the conversation with, wow, we learned stuff and we got feedback, and that was very enlightening.
I mean, I really enjoyed the feeling that you're reading this and that you understood and clearly so that MySQL is so better, that there's so many great tools around MySQL that you still need to develop, like online DDL and stuff like that. These tools are there for years. And then, I mean, that's something that I was reading this and I was saying, look, these guys in Postgres, they don't really have this. So that's why they're asking these questions, because otherwise you wouldn't ask these things.
Do you want me to start on that one or not?
Yeah.
By the way, audience, just wanted to say hi to everybody. Thank you for being here listening to us today. This chat is, I can say, I hope I'm not spoiling your speech, but this is 100% not prepared. I don't know what Goran is going to be asking me to do, to answer. I'm ready for everything. This is absolutely uncensored. Any question I can take from anyone, any moment. I'm not afraid of anything. Let's see how it goes.
Of course. So look, these are the topics you can now read, and then we'll discuss all the things here. But this is something that we're going to pass through today. And before we start with technology, just Alvaro, of course, people understand now that you're doing something with Postgres, but give us a few information on what you do and how do you earn money? Is there money in Postgres? Is there money in the cloud? Where exactly is the money now in your business?
I don't know. No. Okay, so let me make an intro. First of all, some people call me Postgres guy in some communities because I love Postgres, and I've been using Postgres for more than 20 years already, wearing all kind of hats: DBA, application developer, everything. Now, let me say why I'm so focused on Postgres. I'm very focused on Postgres because Postgres has always fulfilled all my needs. In these 20 years, I have never had to look to another database and say, hey, well, I'm missing this, or this given feature is not available in Postgres and I really need it, so I need to switch technology. Maybe it was not optimal in all circumstances, but that's for sure, but so good enough in everything that I needed. So that's why the only times I'm looking to other databases is to migrate to Postgres, Oracle to Postgres, SQL Server to Postgres, and definitely MySQL to Postgres. No, I'm kidding. Mostly it's Oracle and SQL Server. Anyway, so I run a company called Ongres. Ongres means on Postgres. So it should be pretty obvious that what we do, we offer consulting, support, 24/7 support, migration services from proprietary databases to Postgres. As I said, we do training, and we also build software to make Postgres ecosystem more fulfilled, more complete, more featureful. The main software we're developing right now, which is open source, is called Stackres, but I think we're going to talk about that. So it's just a platform for running Postgres on Kubernetes, being the main goal to make it extremely easy, some people say boring, to use Postgres. We want to make you have experience similar. Actually, we want you to have an experience enhanced or better than what you can have with managed solutions. Let's say RDS, one of the best Postgres managed solutions available. But we want to make it better, except in your infrastructure, even though your infrastructure can be on-prem or in the cloud also. So, but we want you to be able to own the infrastructure and then run a service that is as good or even better because of more automation than managed services. And you're asking how we make money in general. How do I make money? Well, I make money through my company, and my company makes money by selling services, mostly, as I mentioned before, 24/7 support. We work with very large companies, 5 or 6 at least multi-billion-dollar companies worldwide. We also do training, and we do a lot of Oracle SQL Server to Postgres.
So now that you have this, now that you have a kid and 24/7 support, how these things work? I mean, are there enough resources? In many cases, I actually managed to get to Aurora team in Seattle to discuss stuff with them because there's not enough people around the world to fix stuff. So how many people does someone need to manage someone like GitLab and is it?
Yeah, I actually been supporting GitLab for quite a long time, 24/7. And it depends, it depends on the customer and the way we structure the business. But we have just some team of people who are rotating on call with several escalation policies and alerts. Doesn't need to be really big. 7, 10 people is more than enough to support this kind of operations. But there's even escalation policies. So officially, I'm on an escalation policy. At some point, I may get a call at 3 a.m. on Saturday night when the baby just woke up. But that doesn't happen frequently. And there are 2 reasons why it doesn't happen frequently. The first one is that, sorry that I say this, but we have such an awesome team. And they're so talented and knowledgeable that they never need to escalate.
Yeah. But it's, the question is everything on you? Because you acquire a lot of code. You acquire a lot of technologies from other people like Kubernetes, like Postgres, SQL code, like, and then something fails and it's not your fault, it's someone else's fault, but still you have to support that and fix that. So it's a really hard job, like especially for these big cloud providers now that they just take the code and then make a service, and then someone has to fix all the bugs, and open source bugs, also bugs of these managed services and companies supporting it.
So it's there's two things here, right? One is that I mentioned before. There's two reasons why we don't get these escalations. I haven't been being paged like in almost 1 year. So that means that, I mean, escalated. So I'm talking about data, right? It works. So the first reason I said is because of the team that we have. The second reason is because Postgres itself leads to a very low number of production incidents. And I've heard from companies that provide support to both technologies, Postgres and MySQL, that it's a ratio for close to 10 to 1, so 1 order of magnitude more production incidents, MySQL to Postgres. But anyway, leaving that topic aside, just want to actually it's factual data that I collected.
Okay.
No, but other than that, what you said is very interesting, because it's the same model that Amazon proposes, right? It's a shared responsibility model. So obviously you need to provide a coherent unit of support where you understand the whole stack. But at some point you need to say, this is really not my fault. And actually, let me bring an example of an unsolved issue that we have right now on Amazon EKS with Stacker. So Stacker's platform for running Postgres and Kubernetes, EKS, Amazon Managed Kubernetes Service. It works there, except on Kubernetes on EKS Kubernetes 1.21. And it's not that it fails, it just doesn't install. And it works on any previous EKS version, and it works on any other known 1.21 Kubernetes version. So it definitely looks like it's not our fault. And we have created, it's because basically in Kubernetes, you have an API to get a certificate. So you send a certificate sending request, a CSR, to Kubernetes API returns you success if everything goes well, and the certificate. And EKS 1.21 is returning success, but certificate is empty. And we haven't figured out yet what's going on there. But we have obviously reported this to Amazon. We're waiting for an answer. And there's not much we can do. I mean, we believe 1.21 is returning success, but certificate is empty.
Sorry.
No, there was no problem.
That's my mistake.
Okay, no problem. So this is the shared responsibility model, right? Maybe we're doing something wrong, but it's extremely unlikely that it's our fault, given that it works on any previous EKS version, that we're following exactly what the API for CSR signing does, and it works in any other 1.21 version. So at some point, you need to say, we understand this, and we can get as far as this. We can work around it. We can propose an alternative how to run this. For example, in this case, just don't use 121. Since it happens that the installation is the choice you can make. But that's it. Now it's the responsibility of someone else, in this case, Amazon, to solve this issue, which probably is also happening.
Thank God people in production, they don't just jump into new versions, especially the latest version of Kubernetes has like a different styles of some stuff, so you have to be very careful. Yeah, well, there is a shared responsibility in security, in management, in stuff like that. So just that feeling that we don't control everything is kind of strange, and then you have to adjust to that in the cloud. But in any case where you acquire someone else's services, you have to just rely on someone else's work, and that's it. You can never do everything on your own. I mean, you can make your own server, but you still need electricity and internet and stuff like that. So there's always going to be something failing. So Alvaro, just let's try to understand what kind of scenarios do we have now to deploy databases in the cloud. And the last couple of years, there was a big jump of several like 3 big cloud providers who are providing managed services in the cloud, and they do that in different styles. So you can have your you can install your database on your own. You can use their managed service, like Amazon RDS or Microsoft is doing and stuff. But then also there's options like Aurora, which is going like a step further, replacing storage. And now in the last couple of, I don't know, maybe a year or something, there's a new offerings around the world. Companies just offering databases. You just go there and use their database. But there's also offering something that your company is providing, like, okay, I have a configuration for you. You just deploy it in your own company, in your own account, Amazon account. So it's so many options. What's your favorite? How do you feel about these things? I mean, the stack of Kubernetes stack is probably is obviously used like a new internet layer that we in many cases like especially those last ones that I just told you. So how do you feel about that? Is that do we see like is there going to be a lot of companies offering, okay, this is how we make some configurations and then you can use that, but is it good? Is it bad? I mean, you do that and just give us an intro on what you do with Postgres.
Okay, yeah. So there's a lot of topics here, right?
Yeah.
So first of all, there's the managed solutions. So first things first, there are, in my opinion, very frankly speaking, because this is uncensored, right? Raw material. There are good services, so-so services. Let's call it that way, right? I'm not gonna make more points on that, but basically, not all the Postgres managed solutions are something I would recommend, or we definitely recommend to all of our customers. We don't. There are some that we don't.
I mean, let's be clear. I mean, it's totally fine if you say that, like, maybe a default configuration of Postgres in Amazon is not that good. Maybe, you know, people are just complaining that defaults are not good in managed services. It's just fine. Just let's say that.
I go farther than that. So
yeah, exactly. Yeah.
So basically, when you opt for a cloud managed service, you want someone to run the database mostly for you, right? Or at least to care about the three main components that these managed solutions bring to you, which is high availability, managed backups, and integrated monitoring. And all bring these three services, but the quality of these three services is not even, and some of them are better. So I will say which one I do recommend, and we recommend to our customers, which is both RDS and Aurora. Those we definitely recommend. Others depends on situations. Now, what is important is to be aware of what they don't provide to you. And this is mostly by design. So I've heard a lot that, oh, you know, we're going RDS because we want to completely forget about our database. That's not true. Databases require maintenance. Unless you're running like a super tiny small database, you need to maintain your database. You need to run the QEMU operations. We're talking about Postgres and reindex and repacks, and you need to tune the configuration, as you very well said. And very likely, you're going to need to set up a connection pooler in front of it. And you know, there's like a lot of stuff going, and not talking about the developer perspective, where you need to analyze the performance of queries. You're going to need to create indexes. You're going to need to work on how to do migrations and data structure migrations, right, and so on. So there's a lot of things that they're not provided by these cloud providers and managed services. And there's also the cost factor. I invite you all to go and compare. What is the cost between running a managed service and the equivalent instances bare bones? You know, if it's Amazon EC2 instances, it's much more than what you expect. So you need to really ask, this is what I want or not. In many cases, it might be because, as I said, for example, RDS, fantastic service, and it's very trustworthy and runs very well. But you know, there's a cost factor, and there's also the fact that you can still not forget about your database. There's a lot of things that you can do.
I mean, can you really forget about the database? When we talk about relational databases, especially, can you really forget?
No.
You can do one DDL command, and then you are done. You can die. I mean, you can, in many cases, you can just die.
Yeah.
So that's.
Yeah. And this is the take where we're trying to take at Postgres. The reason why we chose Kubernetes is not because it's the new hype, the new buzzword or new platform, and we just want to ride the wave. No, we chose Kubernetes because of its API, because it allows us to automate not only the infrastructure, which is pretty much what it does right now, but also allows to start automating or just making extremely that simple this maintenance task inside the system. So for example, to give you an example of what I'm talking about, if you want to run repack is an operation that gets rid of bloat in the database. And it's something that in Postgres, due to how how it works internally, you need to do from time to time. And the way you do a repack normally in RDS, in any or on-prem solution is that you need to install the extension, comes with some binaries, then you need to run the command, you need to understand the command flags, you need to understand how it works, the potential caveats of running it, the locking it takes, and probably you need to create some script. It's going to be a shell script. If it's running on RDS, you're going to run an EC2 instance. Like there's a lot of setup involved. It's not that it's the end of the world. I mean, it's something that is not super hard task to do, but you still need to gain some understanding and knowledge of the system and install the binaries and configure them and pass the correct command lines and script it all and etc. In Postgres, we have fully automated this, and there's two ways to run a repack. Option number one, write a YAML, which is probably around 7-8 lines. 7-8 lines of YAML, it will do everything for you. The only thing you need to know about repack is that it's called repack. Everything else is hidden. We're hiding the command line flags, the configuration, how it's installed, how it's run, what operations will run before or after. I mean, you can look at them, but we're trying to make it that simple so that you don't need to understand how it works unless you really want to. Second option is even easier. Just go to the web console and select drop down, or a repack, select the database, and you're done, right? So this is something that managed services are not trying to get, and it will be harder because of the lack of this automation API. Whereas in Postgres, you can do it very easily. I see you're running Postgres here. Very cool.
Well, that's my Postgres stack. So I have one database, and then it's just easy. It's running. So for people just who are coming from I don't know, from the world of installing databases on their own, what is Kubernetes? You have a definition of some system and then you can deploy that definition to some stack called Kubernetes, which can run on servers in AWS, in Microsoft Azure or Google. And then once it's running there, you can do stuff by changing the definition. System should change. Okay, so Alvaro, just help me here with this. Like with Postgres solution, people are just getting the best configuration for the system, opinionated one. But it's not just the configuration of Postgres. That's something that people are missing. Like because with Postgres, it has so bad connection management. You need to do some like proxy stuff, and you always need some extra tools for Postgres to run properly in big production environments. We have many tools around. Yeah. So by defining this whole system, you just get all these tools together.
Yeah.
And then you do some opinionated configuration of stuff.
Yes.
Am I right?
Absolutely right. So first of all, if you take Postgres and install Postgres from source or from a package management system, like you go to a dep package and just install Postgres, apt-get install Postgres, then you get a configuration that is probably very good to running Postgres on a Raspberry Pi, which is nice, right? But that's not what you're going to take to production. If you use a service like RDS, you get a slightly tuned configuration, which is much better than that. I mean, you're not running a Ferrari on first gear. You're running at least on fourth or fifth, but you can get to 8, right? Probably, I don't know how many gears Ferrari does have, but I guess at least 8. So if you want to really, really extract the most power of the database, you really need to tune Postgres configuration. There's, by the way, a service our company created also is absolutely free. It's called PostgreSQL call.nf. I'll just write the URL here, just in case. And this is a service to check how to, not only the information about the parameters, but also how to tune. So actually, you can see on the chat. No problem.
Sorry.
Yeah, so this is the service. It allows you to either go to documentation, where you can search for any parameter and see documentation and some recommendations. But it also has an API where you can drag and drop a PostgreSQL conf file, and you can edit via the web. You can keep it there, kind of a GitHub for PostgreSQL conf files. Okay.
So it's clear that configuration of Postgres is complicated, but how can you make one configuration that works for everyone? Why is that why is the configuration that you provided any better from, I mean, other people? What's the catch? How can it, and also how can it be like a good one, final one? No.
There are many parameters that you actually need to tune based on the workload. That's a short answer. And we don't know the workload you're going to be running. So we cannot say this is going to be the universal configuration. But there's definitely a lot of parameters that will benefit the rule that we have applied in Postgres. And let's do a live example, just that you have Postgres installed there.
Okay.
Let's do a live example. That what we have, the rule that we have applied. So there's two perspectives on this. Postgres perspective is let's not tune anything because we don't want to harm anybody's. So it's better to run 99% of the people suboptimal so that the other 1% is also good enough. We follow the different approach. Our approach is let's make very happy 95% of the people and maybe slightly unhappy 5% of the people that they will run suboptimal. But the rest will run in a very decent configuration.
So can I ask you a question? Like, do you feel like in the future your stack of all these services could like have an extra thing, like one application to dynamically analyze the system and tune it, like the other tune is doing? Like, I mean, many companies are trying to do something called automatic database or whatever Oracle is calling that thing.
Like, we want to get there, but and I love auto tunes, for example, approach. But I believe that the key to being able to automatically tune a database is less related. This is my personal take. Is less related by letting machine learning infer what are the parameters, and more related to monitoring. I believe we need more telemetry from Postgres right now, or any other database for that matter, but definitely from Postgres to understand how to really tune parameters. So auto tune works very well, and works also very well because the default configurations in general they're really underperforming, right? So it's not diminishing any value. It has a great value because it yields very good results. It's just not that hard. The perspective that beating a default config is easy, right? And on the other hand, I believe services like AutoTune or some of the services will become even better once Postgres offers more telemetry, or this more telemetry is gathered. For example, there's two parameters that they ratio the proportion of the value of this parameter to the other of that parameter relates to the difference in sequential and random speed of your storage media. Well, this is something you could measure, and everybody guesses it, right? They're saying, if it's a spinning disk, we'll make it 4-to-1, being sequential reads 4 times faster than sequential. If it's an SSD, let's call it 1.1 or 1.2 because they're almost the same. But you can measure this, right? So there could be the option, and actually not only measure on a static test, but you could check the operations that are sequential and they're random reads or writes in Postgres and report them to a system that will tell you, oh, this is the value, and then you'll get better results. So just let me show you one thing, if you don't mind going back to the stack.
Yeah. Please. You want me to show my Postgres? You want to show yours?
Yeah. I don't have it installed because you asked me for a demo and I have Kubernetes cluster. But go to yours. Yes, why not?
Okay. Let's try it again. So let's see. I mean, I have one.
Okay, so go on the left pane. You've got configurations, and there's Postgres. So click on the plus sign to create a new one.
Okay.
Yeah. Give it a name, whatever you want. Okay. Select the major version, like 14, which is the most recent one. And let's tune some parameter. Let's call, for example, work_mem. And let's set this parameter to, let's say, 16 megabytes. 16 MB altogether. That's Postgres syntax.
That's it?
Yeah, probably you don't, the space, yeah. You need to remove the space for this to make it work, but that's okay. This will be improved between the 16 and the unit.
Oh, sorry.
No problem.
Okay.
All right. Now look at this configuration. Click on Alvaro 1 there. and look at the default parameters. So here you can see all the parameters that we're tuning for you. So you only tune one parameter, right? Work mem, which should be at some point there. If you start scrolling in this default parameters table that you get there, you have scroll window, and you will see if you can maybe Goran, you can scroll down there. There you have your work mem 16 megabytes. That's the parameter that you tune. But look at the rest. These are all the parameters that we're tuning for you. And each one of these parameters have been very carefully thought. And we're not there yet. This is going to keep on improving, and even next versions will deploy more parameters. But this is, the kind of things that we're trying to recommend you. Like, this is our default config. You can override most of them if you want to, if you're an expert, or do you disagree with us? And obviously, you can even also submit a merge request on GitLab and say, I disagree with this parameter. I propose it to set it to this default. We're adding dynamic parameters based on your instance size later on. But this is one of the efforts we're doing.
Okay, can I ask you one question? Like you see, like the offering on the net, what's on the market, and how do you value companies that offer some kind of auto tuning, like suggesting the best configuration for your needs? I mean, how do you feel about that? I mean, do you see the value of those newcomers to the market that promise like some super auto scaling? You don't have to think about anything. Why would I do these things? I mean, and on the other side, you see Amazon, who has no offering on auto configuration or auto tuning. It's just it. They say, okay, we have a super fast like a storage layer, but that's it. I mean, there's nothing else. So is it missing? Do you see that's coming to Amazon or others?
So my point is going back to the same topic. There are certain parameters like these ones that you're seeing there that they can be tuned, and they will probably work very well for 95% of the people, right? And so you can tune them by default. But the rest of them, there's maybe another 20 or 30 parameters that for a production workload we'll probably want to tune. Those are going to be much more dependent on the workload, which is something that you don't know beforehand. You need to understand. Can automatic tools do that? Yeah, I haven't seen the technology to do this yet. I'm not saying it cannot be. And what I've seen that is used a lot, and this is surprising to me, is very simple tools, which are kind of a web form where you fill in 3 items of data, like what is the number of cores of your machine, the RAM, and whether you want OLTP or OLAP kind of workloads, and then they give you a configuration and say, try this. I mostly disagree with those tools because the recommendations that they deal based on that very low quality data input may even be in detriment of your performance. So it still as of today, I would say it still requires database expertise.
Yeah. So you think that, like, if I may interpret what you just said, like, let's leave some agent to cover your workload for like at least a week or a month, and then once we see the pattern, maybe we can get something out of it. Like, what's the configuration for the morning? What's the configuration for the afternoon and high load days and stuff like that? Is that what we can do now? Do you see that's something like that could be used now? Because some things can come without configuration, like Amazon serverless v2 should be able to scale vertically, and by doing vertical scaling, adding like extra CPUs, extra memory, they need to reconfigure some stuff. It's just you need to tune some stuff for the new memory, for the new CPU. I mean, some of these things could be done online, just like that. So maybe we don't really need that much auto tuning at the end.
My perspective on this, how to solve this problem, is to be able to really capture production traffic, which is something that is not easily done today. Like to get a log of every single query thrown to a database with their timing, and be able to reproduce it elsewhere. And then iteratively tune all the configurations and benchmark them with the same production data, or even multiply by 2, by 3, by 10, by 100, and see how your system reacts under those different conditions with a lot of configurations, and then get conclusions. That is the best way to try with production workloads, which is also, of course, is not easy. But
maybe once you have like a giant database with so many different workloads, maybe to have a proxy in front of it just to split different kinds of traffic, like giant reports from some other kind of exports or stuff like that, just to split the traffic and then to scale separately different readers or different instances.
Yeah, that's
sometimes you just need to split the database. That's it. So maybe maybe you cannot tune it anymore. Okay, so how do you feel about these new databases coming to the market? Do you see that like some of these databases even have a Postgre, like Yugabyte have a Postgre layer of compatibility?
Yes.
So so we have two topics about that, like Postgre as a perfect backend and Postgre as a perfect API. So
that's a very fair characterization that I haven't heard a lot, and I think it matters a lot. It's very good point. By the way, not all of them are that young. They have quite a history, I would say. But yeah, they
just raise money, you know. That's where they start.
And a lot. Yugabyte raised a lot of money.
Yeah, a lot of money. So
I know there's some Yugabyte people here. So the API. Let's start with the front side, right? The API, Postgres API, Postgres protocol compatibility, SQL compatibility. I think that it's something that has gained a lot of traction. Like everybody wants to be compatible with Postgres protocol. I don't know if this is good or bad. Actually, the protocol itself, it's something that it's already time to get a revamp to the protocol. Postgres protocol dates from the dates of 7.4, which is kind of like 15 years old, and the protocol has not changed since then. However, if you go to the Postgres wiki, there is a page about to do with the protocol, and there's an aim to write a v4 of the protocol. Current version is called v3, and there's so many things to do there, so many improvements that it has to happen at some point, and it's not going to happen, by the way.
And it's going to break the internet, you know. Once we have a new protocol, what then, you know?
So it's becoming kind of a good thing, because everybody is compatible with Postgres. On the other hand, it's like, yeah, this is going to make it even harder to improve the protocol, which definitely deserves a lot of improvements already. But anyway, I'm not gonna judge that, because in general, I love that all the databases want to use Postgres protocol, and that's a very cool thing because it standardizes tools, and I see that as a nice move. Postgres as a backend is a different story, because Postgres as a backend has good things and bad things, like any other database. For us who operate Postgres a lot, to have a different backend is sometimes a problem, because you're used to Postgres working for the good or the bad in a specific way, and then you switch to another backend, and even though it feels like it's Postgres, in reality it doesn't behave like Postgres. And so the classical problems that you have in Postgres that you know how to solve, either now they don't show up, that could be good, but all the times they show up in different ways, which you don't know how to solve. So all this operational experience, all the tools I use with Postgres that we're used to as now wearing a DBA hat, they may not apply to all the databases that are Postgres compatible in the front, but different in the backend. And I'm not saying they're worse in any way. Maybe they're even better, but this operational expertise that is a lot of what is existing is a different story. So those are significant differences that I see few people considering. But now, so for example, I think these databases bring, anyway, regardless of Postgres compatibility or not, they bring a significant value, right? For example, well, the three actually that you mentioned there, I like them, the three of them. Yugabyte, it's what I wanted always a database to be, right? Like something where all writes go through consensus. Consensus, by consensus, I mean distributed consensus algorithm. In this case, Raft. I like more Paxos, but that's just taste, right? They work equally well. And so what it does is that technically it's a purely distributed database. And this is very cool. What is interesting to understand is that it is subject to different rules by choosing whether you want to go this route or not.
So just to be clear,
sure,
Postgres and other stuff deployed in Kubernetes cannot really be completely distributed in a proper way, so that's like that's just a dream, so
yeah. Postgres is just a stack. The name says it all, is a stack of components on top of Postgres. So
but you have master and then you have readers.
Yeah, exactly. So for the good or the bad, Postgres is a layer on top of Postgres, not even a layer, it's components around Postgres. We actually call it a Postgres distribution. So we take Postgres as if it were the Linux kernel and surround by tools around it to make it a distro, something much more usable. But it's still the same Postgres for the good and the bad, right? So Yugabyte is a distributed database, which means that you transparently can scale to any number of nodes, and you don't need to care about this primary secondary structure. But there's nothing free in this life, and you really need to understand whether your use case fits or not fits. For example, regular Postgres scales vertically really well. Speaking of the customer that we had that you just mentioned before, GitLab.com, and these are public numbers, so I can definitely disclose them. They're already disclosed in public. They run a cluster. Everything runs on their single Postgres cluster with a high number of replicas. And it's doing more than 300,000 transactions per second. 300,000 transactions per second. And it can scale probably 3 times more comfortably. So maybe they can do 1 million transactions per second in a single Postgres cluster. So how many people do need more than this? Not many in the world need more than this. So when I hear people like, oh, I'm going distributed or I'm going sharding because I have a high volume, and then they go on the tens of thousands of transactions per second, I say that's fine. Maybe that's a good choice. But bear in mind that vertical scaling, Postgres can really vertical scale very well. So it's just that you need to analyze the trade-off, not just saying, oh, I want to scale Google size, so I'm going distributed. Well,
but you can always make a bad query. You can always make a bad thing, and it's not just you, expert, who is doing something on the database, and someone is just ruining everything. And then you need extra power, and then these 300,000 can be just easily smashed, by someone else's query. We are sharing the same space. We are sharing someone can punch you. Yes,
there's the latency trade-offs. On a distributed system, you're going to face more latency, and you're going to need to be care of how your data is sharded, because data is going to be sharded, and you need to understand how it's going to be the sharding. If you have a data set or a pattern of usage that is not very good with sharding, you'll probably get poor performance. So like any decision in IT, you can just not say blindly, oh, I'm going to pick this technology because I want to be Google size, right? Which everybody wants and not many people reach anyway, right? So you need to understand the trade-offs. Same happens with Citus. It's a fantastic product, an open source commercial version and managed on Azure, and allows you to take Postgres and shard it and do distributed queries. So it allows for scaling Postgres to massive numbers, much more than what you can do with vertical scaling. But it will not work well if your data is not shard, it has a structure that doesn't shard well, or you're doing a lot of cross-shard, cross-nodes operations, which are permitted in Citus. So you really need to understand your use case. Planet scale is something like Citus on MySQL, but more focused on OLTP. Citus is more focused on OLAP. It's not that either is exclusively focused on each, but it has and this reflects on a different architecture. So I think from this perspective, Planet scale may be more general use case or more OLTP use case. But it also comes with, I would say a lot. I don't know if that's a fair qualification, but certain limitations, right? Including the inability, for example, to use foreign keys. So you need to make trade-offs when you're gonna choose these solutions, and they're very good solutions. The 3 of them. You just need to understand that that's what you need in this particular moment.
So once we go to the cloud or any distributed system, we need to decide on some things, like one of the things that I brought in one of my applications was the distributed transactions from Java. And that caused me a lot of trouble. And one of my clusters, Aurora cluster, like was down for 6 hours because they just couldn't fix something, and distributed transactions just don't really work and in the cloud, and you have to think about that. And so it's like DynamoDB is based on the idea that you just cut all the functionalities to the minimum, and then if you can make it with that, then you're going to be fine. So I mean, we can I mean, thinking that way, we can easily forget about any API except SQL language or just basic functionalities, and that's it. If you get deeper into special functionalities, into special expectations from the databases, then maybe you will fail in the cloud. So why is this Postgre API so important when 90% of developers don't use anything extra but just SQL language? So what is that API that's so, what is it in the API that is so important? I don't care about stored procedures. I don't care about functions. I don't care. Well, maybe someone cares. I mean, is it that many people that write stored procedures now that do
No.
serverless? It's just, why is it so important? Why would I care about the Postgre API?
Well, I think it's just a combination of two factors. The first one is very simple to understand, is just trust and reputation. Postgres is a very well-reputed database. I mean, some people prefer MySQL, and that's absolutely fine. But I've seen very few people questioning Postgres. Some people say,
I'm just questioning API importance.
Yeah. But why some companies and some products and databases decide to be compatible with Postgres? And I'm saying one of the reasons is trust, is reputation. If you're making compatible with something that people love and consider as well reputed and trust and stable, then you're making your product look better too. So I think this is a reason. This is a very simple one. It's just non-technical reason, but I think it's one of the reasons why the Postgres protocol is picked. The second one is just related to the amount of effort to create your own drivers. So basically, a database is not just a database, right? It's the protocol with which you use to interact with the database. And to interact with this protocol, you need drivers. And the drivers need to be integrated into the tools, into the ORMs, into the data migrations tools, into the GUIs, into everywhere. And coming up with a new one, if you invent a new protocol for a new database, it means, first of all, you need drivers. So for all the existing languages, 30, 40, 50 languages, you're going to need to develop drivers. And then make sure that the frameworks integrate those drivers, and then the tools, and then the GUIs. Is almost impossible as of today to come up with, let's say, a new radical protocol.
Just give me one hint. Like in the world of distributed world, shouldn't we focus more on APIs which are based on HTTP and not those which are based on binary connections? Is that, I mean, if you really want to be distributed, you cannot just stay with the binary connection, which is like open. And then, I mean, is it, why is that so important? I mean, can we just make a assumption that like some kind of data API can just work through HTTP, and who cares? Is it like the performance that we really care today on these things? DynamoDB works through HTTP, and it's like a super fast, super scaled, super distributed. So who cares about binary drivers?
So there are caveats on using HTTP APIs, and DynamoDB is super fast. Well, let me question that a little bit. I love DynamoDB. I think it's a fantastic, incredible technology. But if you want really low latency, you're not going to get really low latency with that. And let me put a number. So DynamoDB runs, it claims to run, and most of the time runs below 10 milliseconds. But with Postgres database, you can get queries in less than a millisecond. So it could be even one order of magnitude faster. It depends on the query, obviously, and has many other caveats. So I'm not comparing pairs to pairs or apples to apples. But yes, there is a point in using a TCP protocol for lower latency when the query may run that fast. But I absolutely agree with you on this area. This is one of the areas of research that we are investigating. I mentioned before that the Postgres protocol needs to be revamped. And that doesn't mean, in my opinion, that it needs to be a TCP protocol. I mean, it could be TCP under the hood, but it could be HTTP. In particular, what I'm really interested is considering a gRPC-based protocol for a database, for like Postgres. And there's a key concept that you just mentioned that I'm grateful that you mentioned, because not a lot of people mention it, which is the fact that you don't need to keep a connection open. In other words, that if you're throwing a transaction to the database, as complex as it may be, it would be what I call non-interactive transaction, meaning that all the data that you need to run the transaction, you know beforehand, and you send it. You can throw 1,000 commands to the database within a transaction, but you know them all. You're not waiting for the database to give you a response to a query and then use that value to craft another operation within the transaction. That would be interactive. And interactive transactions, in my opinion, are totally against scalability. They just break everything. They need to keep resources open.
We need real async, real async in the cloud. So
absolutely,
just send something and forget it, and then come back to that, like you can do with Athena queries and now with Redshift queries. Like, did you try Data API with Redshift?
Yes, but Data API
with Redshift, you can make a call.
Yes.
You can get the ID of the query, and then you can get back when it's done.
Yes.
So that's cool.
And so the key to me would be, yes, to start exposing also non-TCP, custom TCP protocols for databases like Postgres, but also HTTP-based ones, because it makes drivers so much easier to build. And in particular, I believe gRPC is a great fit for that. So yeah, there's a one line of research that we are following using this approach. And by the way, let me briefly, I don't know if I'm skipping a lot of the topics, but there's an opportunity here to do this via the Babelfish project. The Babelfish project, among many other things, is introducing a hook to allow for more than one protocol in Postgres. And this is key to opening the door to have more than one protocol implementation for the database. And this opens the door for new protocols, like what I'm mentioning right now.
Yeah, I mean, let's just say a couple of words about the modularity of the Postgres. And is it a problem for the Postgres to be really scalable and distributed? Can we add extra modularity to the system and then be able to easily replace some stuff? And where do you see that maybe Postgres is missing some modularity, or how do I say that? So, because if you split so many things, if you split some of the parts of the Postgres system, maybe you can get it like to be scale. Maybe some parts can scale separately. Maybe they can run in a different way or different clusters or whatever. So, which parts should we like modularize and then be able to replace, and to get Postgres better in the cloud?
So there's two topics, right? One is scalability, and the other one, more or less, we can call it break the monolith.
Yeah, that's the first, break the monolith to get to better scalability. Yeah, exactly.
Yeah. So on the extensibility side, Postgres is extremely extensible. There's many ways in which you can extend Postgres, both from a user perspective, like you can create data types, functions, operators, procedural languages. You can do a real lot of stuff. But also from the Postgres developer perspective, you can create new table storage backends, new indexes, and new procedural languages and extensions. And Postgres extensions on the some can turn Postgres into a distributed database like Citus, time series database like Timescale, geographic specialized database like PostGIS. Like you can do really a lot of stuff. The only extensibility point that I'm missing is protocol hooks, which is what Babelfish is bringing to the table. But on the topic of scalability or breaking the monolith, I think from that perspective, Postgres is not very modular. The code base is very intermingled. And for example, this is not related to scalability, but one component I would like to be a separate part of Postgres, part of Postgres project, but kind of a separate library and could be a dependency to the Postgres code itself, is, for example, the Postgres query parser. The query parser needs to be used in many products outside of the database, proxies, toolings for compliance, like firewalls, query firewalls. Like there's a lot of opportunity for doing a lot of things. And the query parser is very hard to extract from Postgres. There's actually a very cool project that does that, and it's going through a really complicated means to be able to get a parser separate from the Postgres database that is compatible. So there's many opportunities for modularization of the Postgres source code, but to really separate some components so that they could scale differently and independently, I think that's a huge step ahead. I don't even know if Postgres.
So how do you feel about like how hard was for AWS team to make Aurora for Postgres? So I just made one slide to show, to explain to the people, to everyone watching this, maybe who are not familiar with Aurora. It's like a new storage layer in the system that is actually, if we can compare that to Postgres, it's just another list of servers, like pods that do some job in the network. So I have several questions here. So first one is, how do you feel how hard it was for AWS to replace a storage layer?
I bet it was very hard. I mean, not impossible at all, but I bet it was definitely a good effort, even though the storage subsystem was already built in, because it goes farther than storage, right? You need to change how buffer pool works, how applying, how checkpoints work, background writer, replication. There's no replication essentially. Replication goes through the storage layer, so it's a significant change. I'm sure about that.
Yeah, and on the second thing, the question is like, can you make something like this in Postgres? Can you make your own like storage layer?
I mean, a Postgres philosophy is not to modify Postgres, because we want to run the same Postgres that anyone does. You can run on your laptop as is, but we're definitely trying to remove some components of Postgres and replace them by components that are already built and developed that are part of the Kubernetes ecosystem, the CNCF ecosystem, that do that job better. Let me give you a very precise example. Postgres supports encryption of connections with SSL, right? And but SSL is not cheap, especially if you're not using a connection pooler at the application layer. SSL establishing connections becomes quite expensive. And your database is because of this architecture that Postgres has, that is primary and multiple replicas, you really don't want to overwhelm the main node with SSL, and like the least stuff that needs to do is focused on the database pure stuff, right? So one thing that we've done in Postgres is, first of all, we have engaged with the Envoy community. Envoy, this proxy that is being mostly used in Kubernetes land, but not exclusively. It's a fantastic proxy, and it has a plugin architecture, so you can develop plugins. They're called filters for Envoy, and we, in collaboration with the Envoy community, we have developed a filter for Postgres. So basically, Envoy can proxy Postgres traffic, understand the protocol. It sends additional metrics to Prometheus for monitoring, and we have implemented support for SSL termination, which means that we offload the SSL termination capabilities from Postgres to Envoy. So we're relieving Postgres from having to do SSL. Why? Because we have an Envoy which can do it better. And Envoy is fully programmable. There is even tools to manage this programmatically, and you can do certificate rotation and manipulation in a pure native Kubernetes way. And so we're making Postgres simpler from this perspective.
Yeah, but that's just something that's coming extra to Postgres. It's not something that you try to do inside the Postgres.
Correct. Correct.
That's I could say that was easy.
Well, yeah, I mean, it wasn't as hard as building a storage engine. That's for sure. Yeah. There is some projects that I believe I'm trying to follow that route to implement something like Aurora storage. But in general, our main principle of operation, we want to offer for the good and the bad, which is mostly good, the same Postgres as anyone else. We just want to work around it and offer additional capabilities around it, but not replace internal capabilities.
Okay. Give me a second. I just want to say something about the community called Data on Postgres. on Kubernetes, sorry, data on Kubernetes.
They okay. They okay.
Yes. That's an amazing group of people who are organizing almost weekly, if I'm correct, like meetups and
several per week.
Sorry, even more.
Several per week is amazing.
Yeah, that's amazing, and I really suggest everyone to watch these videos, and they're really trying to teach people like what's inside, what are the problems. It's not just like that they're preaching something. It's really good that we have to discuss what is there. You know, even we by making these database systems in Kubernetes, we are trying to emulate what big cloud providers are doing. You know, it's just like kids trying to do the same thing for no money, with no money. You know, it's just crazy. You know, try to simulate all this stuff. But anyway, and we really engineers want to understand what's inside, want to really try to get there, you know, and make it in a way that can be reusable all around the internet, across any kind of technology and stuff. So it's good to understand what big guys are doing, you know, so and try to do that in Kubernetes. And I see that many people are enjoying that, giving it for free to the community. Okay, so the next question for you is like the feeling of like, what are the big risks when we talk about data on Kubernetes and anything on Kubernetes, you know? So when we talk about the servers, it's just servers are going up and down, and you can lose a server, but you should not lose data. Data has to be saved somewhere, and then to persist whatever happens to the system, you know. So the question is like, how do you feel about the storage? What's the storage now in 2021? When like 20 years ago we were always thinking about the hard disk, about the, I don't know, tape or something. Anyway, like there's a hard disk, but when you look at this image with Aurora, it's not the hard disk. You are sending some data to some servers, and when there is a quorum, you say, okay, I'm fine, I don't care. Someone should just save that to the database, and that's it. I have to trust someone, and they're doing that pretty well, you know. So you can just send that to some other pods in the Kubernetes cluster, and they will save that data. So it's just two servers communicating, and the other server is saying, I am the hard disk. So how do you feel about this, like feeling that the storage layer is kind of like not really that fixed in Kubernetes? Like I'm feeling strange to believe that my data is properly saved, or what's going to happen, you know, if someone just makes one command in the wrong command in Kubernetes or something, and I will lose my data. So how do you feel about that? What should we say to the people?
So I feel actually very safe. I would say it's probably safer and definitely more available architectures you can get than in non-Kubernetes. So let me explain this. First of all, I wrote in the chat an opinionated piece I wrote recently at the News Stack that touches on this topic. So if you want to dive deeper, just feel free to read that. Now, so there's two topics here, right? One is about what is usually called the ephemeral nature of containers. And the other one is about the storage that you're effectively using on something like Stackers, like something like, you know, a serious Postgres or database on Kubernetes stuff. About the ephemeral nature of containers. Containers are considered to be ephemeral. But what is a container in reality? A container is kind of an abstraction, yes, that one, over a process or a process hierarchy. And if you look at that, a container lifetime is not that much different than the process running inside that container. So if your process is stable as Postgres, your container will last as long as the process does, right? There's a few exceptions to that rule, but in general, that's what it's going to happen. If you run inside of a container an application that crashes every 3 minutes, your container is going to crash every 3 minutes. And there is ephemeral storage inside of the container that will go away with your container, but nobody would, in its sane mind, use that for storing data for a database. You use external storage to the container. So that lets me get to the second point. And is that whenever you're using something like Stackers, for example, or any other thing, all the storage is external. And what means external? Well, could be something like EBS on Amazon. And so you have the same reliability that using an EBS disk on Amazon. No less, no more. If your container dies, the storage remains there. If you delete everything with the command, it's the same as if you do an rm-rf on your EBS disk. The good thing is that there's multiple layers of protection in any case. First of all, if we're talking about Stackers with Postgres architecture, you have several replicas. You're going to have n number of exact copies of the information, one in the primary, one each in the replicas. Those are independent disks, and each of those disks could be a separate EBS volume. I mean, will be a separate EBS volume. So you're going to have multiple volumes, which in and among themselves, they're all highly redundant. They're managed by the cloud provider, and you will have, from that perspective, a lot of redundancy, a lot of copies of the same information. But you can also use software-defined storage, like something like OpenEBS. And software-defined storage, you pull resources from potentially multiple disks running on potentially multiple machines, and consider that a virtual disk and expose that to the pods and use this in Kubernetes with a Stackers. It's very easy to run this configuration, and you have a lot of control over how many copies and how many replicas you want of the storage. It's actually something like what the Amazon EBS does behind the scenes, except that you have full transparency and full control over it. So you can screw up like in any other system, obviously, but in general, you have multiple layers of protection for the storage. And on top of that, obviously, you have backups. And something like Stackers provides automatic backups with retention lifecycle for you. So even in the worst case, you explicitly leave your data and it gets all replicated across all replicas, then you can still restore from a backup.
So if you just do kubectl, like delete or something, I mean, can you lose data?
Well, you have backups for that, but yes, I mean, if you destroy your cluster, it will destroy everything. Yes, but for the most cases, no. If you delete a pod, you'll absolutely not lose any data. Not even the disk. The disk will be there. Actually, deleting a pod in Stackers is you'll see that it takes like around 10 seconds or less to get it back online, because the data doesn't need to be reconstructed. If you're running on EKS, for example, it's going to be using EBS disks by default, and the disk is just going to remain there. So it's going to be the process that's going to die. It's going to be restarted, potentially in a new node. The EBS disk is going to be reattached, and you're going to be back online. So it's going to be a matter of seconds.
Okay. So can you just tell us about what you are actually selling something with Stackers? Okay, you're selling support for it.
Yes.
And why do you think someone needs support? If it's so good, if it's so stable, if it's, what are the risks, and why do we need people in this game? I mean, whatever we say about the automatic databases, blah, 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 at the end, we look for someone who will help us. Is that because we have bad developers, bad data modelers, or who is the bad guy in this game if the database is good?
Well, I think it's all about assurance. When you run a business, you want to minimize the risks. Running a business is a risky thing on itself. Everything is almost against you, right? Against the business. Everything is every mistake may just make a business go bankrupt. So one of the keys, and I know this as a business manager, is to minimize risks. And if a database is core to your organization, which most of the times is, you want to minimize risks with the database because it's an obviously a factor that may bring down your company or significantly harm it. And so that you want assurance. You want assurance that if something fails, you can call someone 24/7 anywhere in the world and get a response that will help you fix this. The sooner, the better, right? So even if Stackers, let's start with Postgres. Even if Postgres is extremely reliable database, and even if Stackers is, I would say also because of our experience so far, very stable. And in general, Stackers is just orchestration, right? It just doesn't get into the way of Postgres. So if Postgres is stable, it will remain there. Why would you need support? Well, the support that we sell for Stackers is similar to what Red Hat does. It's a subscription for getting support. And it's just, again, providing assurances to companies. They want to make sure that if they have a problem, it doesn't matter if they have 1 or 2 problems or 10 per year. It doesn't matter if the number is low. What they want to know is that if there is a risk, they'll be able to mitigate it.
But what are your, I mean, what are the primary risks in having data on Kubernetes running in a way that you just proposed using Postgres? And what should we be scared of?
There's
I mean, not. I mean, we will not die, of course. Just what are the main topics to learn? You know, we want people to deploy something, and then we say, okay, that's it. That it works fine. But they still need to understand what's going on. So, what are the main issues for people to understand? Like, should they're running something in the cloud? Okay, so there is one risk of a cloud provider having some issues. Okay, then you have to understand that this is coming. The problem is coming from provider, not from your stack. Then on the other place, there can be someone could change something. How can I see the differences? Like, so what happened during the day? Who changed something? So what are the? Can we like can we say that that there are risks in terms of versioning of the configuration, like versioning of the system? Can we say that the risks are in monitoring stuff which are not relevant, and maybe some stuff which are relevant, and some things could be out of the scope of the system because you don't really understand what's going on in your cloud provider? So,
those are all valid risks. What I want to say is that there's no additional risks for running on Kubernetes by running on bare metal or VMs. I think actually it could be even less risks because Kubernetes provides more resiliency mechanisms. Like, let me give you a very simple example. If a node fails, one or several of your pods may die, but Kubernetes will reschedule them on another node. Actually, it will even fire up a new node automatically and to bring capacity up, and then deploy all the pods there. It will happen all by default, all transparently. If you're running Postgres on your own EC2 instances, for example, this will not happen by default. You could do it, but it's far from trivial to do it. And actually, my experience tells me that most people don't do it. So normally, if you're running Postgres on your own, not managed as a cloud provider, and if an instance dies, it requires manual intervention. This will not happen in Kubernetes. That's what most. It's not that you cannot do it. You can do it, but most people don't do it. Whereas in Kubernetes, this almost comes by default. It definitely does with Postgres. So the risks are similar. I would say maybe even less, but they're similar. But again, it just comes back to the same point, right? If you're a business and there's a problem with your database, you don't want to figure out by yourself whether that problem is from Postgres itself or from the cloud provider because EBSs are timing out. You want to have someone to go and check it for you. And that's in my opinion, what the key is.
Okay, so we are pretty fine with that. Okay, so Alvaro, I mean, just I have this strange feeling that people went from like being on premise to trusting some cloud providers, and going back to say, okay, I don't want to trust too much because like all these cloud providers had some issues at the beginning, but they're getting better. So I mean, I had the similar experience, like going back so fast with the cloud provider, but then going back and say, okay, wait. So the thing is, like, people are going back to trying to understand better what are their workloads and trying to fix that before they go back again to the cloud. Okay, so do you see at the end that there's no? Do you see that at the end we are going to end in the cloud again? In a managed service, or do you see that there is a future in people going this way? Because it's so hard, you have to learn so many things, and then we won't be able to cope with all this with all this knowledge. So like how hard is it to keep with this with the Kubernetes and all these things?
I think the future is going to be, let's call it hybrid. I'm not sure if hybrid is the right word because it's been a lot misused. But I think the ability to run workloads where you can easily choose whether those workloads are going to run on a cloud environment or your on-prem and so forth, I think that's very important. And that's where I see precisely a lot of value on Kubernetes, because it makes move your workloads, even if you don't want to move, or just because you want to split the workloads or because you want to reconsider, or you have the option to actually move workloads, is a fantastic value proposition. And that's the main reason, together with automation, where we picked Kubernetes for developing Postgres. Again, it's not because it's super fancy stuff. It's just because it's an API that is mostly abstracting away the storage, the networking, and the compute. So, for example, to say something very practical, running Postgres cluster on Postgres on-prem on OpenShift, or running it on EKS on Amazon, probably doesn't even need to change nothing on your YAML deployment scripts. Maybe just the name of the storage class on a few places, like it's changing a name on a YAML file, right? This is very, very low friction ability to move to completely different environments where you don't need to learn new APIs. And definitely goes much farther than Terraform or Pulumi or similar tools, because they're mostly focused on the infrastructure, whereas here we're focused on the application components themselves, right? So I think the future is going to be able to seamless move or execute or do things across environments. For example, Postgres by default, all backups, they have to go to cloud, to object storage. Whether that's going to be on a cloud or a software-defined cloud storage like MinIO, that's up to you. But I recommend to use cloud storage. So even if you're running on-prem, send your backups to the cloud, because it's just much more reliable than anything else. So it's already kind of a hybrid architecture from that perspective, and Kubernetes makes it pretty seamless.
Okay, so I mean, of course, Kubernetes is definition of complicated. So everyone who wants to go to the Kubernetes, just please read as much as you can, and before you just jump in and watch all the videos from Data Kubernetes group. So one last topic to talk about, and the one that we mentioned at the beginning, is like the Postgres community is. So what is wrong with the Postgres organization, or what are you trying to achieve? Are you doing some like self-promotion or promoting your company, your business? Why would you upset so many people around the world and trying to what are you trying to do? What are you trying to achieve? Because many people are just fine with whoever runs Postgres development, and it's just fine. What's bothering you? Why is Alvaro so upset?
No, Alvaro is not upset at all. I'm just trying to think further, to go beyond, right? And so it's not that I have specific problems. I'm not trying to make anyone unhappy. Actually, I was trying to do exactly the opposite thing, but it turned out not that way at some point. But my point is the following. Actually, I want Postgres to move forward and to move faster, and I believe there's many things that are keeping it to unleashing its full potential. So everything, if you look from a from a outside perspective, Postgres looks like everything is perfect, right? Postgres is growing significantly in popularity. The features coming each year are making it better and better. Everybody loves it. It's becoming the last 4 years, it has been named the database of the year 3 times, so 3 out of 4. So everybody's happy with Postgres. Nobody's complaining. Looks like brilliant. Like everything is perfect. Ideal world. Now, okay. So what is the market share of Postgres? Because if it's so perfect, it should already be competing head to head with Oracle.
With
it
MySQL.
Should have already, exactly. It should have already run MySQL into oblivion, because it's also run by Oracle, right? And if you look at the numbers, and I don't have definite numbers, but Postgres market share is probably anywhere between 1 or 2%. And that's not good to me. I mean, everything looks very good. Everything is, we're all jumping in a flowers field, but in reality, Postgres is not doing good at all. Or it is doing good, but could be doing much, much, much better. So Postgres is ideal. It's one of the most featureful databases. It's fully open source with a very liberal license. It's not run by any specific company that a lot of people hate. It's free. You don't need to pay for it. It's extremely well reputed. It's one of the most desired databases by all surveys. It should be really conquering the world, and it's not conquering the world at all. It's doing very well, but it could be done much better. So the cost of loss of opportunity is my main concern. And why is that? So there's many reasons. I believe that Postgres in general is a database that I mentioned before, where the community behind Postgres, and I love this community, and I know a lot of people. I have dozens of friends, but most of the time is looking to itself. Sometimes I call Postgres database developed by developers for developers, not for users. I see few lines of feedback from the user community, from the companies, from the big cloud vendors, feeding feedback or this feedback being asked and being captured on how to improve Postgres. You look at features that Postgres, that people have been requesting features, which make a lot of sense. They're not wild. They make a lot of sense that having been requesting for more than 15, sometimes even 20 years, nobody paid attention to them. So Postgres is not listening to the market. It's not listening to what a lot of users demand. Postgres is improving every year, but when you look at what is in a release, everything is good. The question is, what isn't in this release? What didn't make?
What are the top things that you would like that you would complain? Like, what is the first thing? Okay, like I want this thing to be done. What would be that?
Like integrated HA and integrated connection pooling and a new protocol, and those are huge topics. They're so huge that nobody's tackling them. Because
who cares? You have so many you have many bouncers, whatever proxies.
Exactly, and that is a problem by itself because users don't know which one to pick. And if you pick one, how do you configure and like the experience when you go from a proprietary database where everything is integrated, and then to go to Postgres looks like the Wild West. You need to pick this tool from here, this tool from here, this tool from here. Do they work well together? This one has this config file with the style, the other one with this. It's actually that's the value proposition of a Stackers. We're building the stack together. So, I mean, for us it is pretty good, but that's not what I want for the community. So this is one of the problems, in my opinion. It's not.
So when you say Postgres, what do you mean? Who is that Postgres? I mean, when Postgres is not doing that, Postgres is not doing that.
So that's not a very interesting question because there's not a good answer for that. So, and this is the second topic that I've been trying lately to focus. The thing that is a distributed project and an open source project doesn't mean that it should have a solid organizational infrastructure behind. Look at the Linux Foundation. I see Postgres and Linux very similar in terms of how they are kind of developed and distributed and not owned by a single company and so forth. But Linux is backed by a very solid entity called the Linux Foundation. It has a very clear governance structure. It has a very clear trademark and intellectual property policies, and it is a safe structure. It's a structure that nobody will take over easily, and it has governance mechanisms. It has input from user communities, input from commercial entities. It's very diverse. It's rich. It brings feedback and makes it grow as Linux has grown. Now, Postgres doesn't have anything comparable to that, and it's okay how things have been built so far because probably the way they have built was the best way at that time. But today, 2021, I see from a governance and structural perspective a lot of problems, and I've been trying to suggest these problems to the more or less governance boards that exist for Postgres, which are very loose anyway, and they don't seem to react positively to these changes. It looks like they're change averse, and I believe this change is really needed. Specifically about trademarks policy, I see a risk in where these trademarks are deposited right now. The organizations that are elected to be the stakeholders, the holders for this IP, they're not solid and they're not transparent. And this is very surprising. They should be extremely solid from a legal perspective and definitely be transparent. It's surprisingly that such an open community is an open source software, the boards governing it are extremely opaque. So
what you did is like you asked for trademark. Okay, so you applied for it and you got that for.
So for example, talking about trademarks, there is supposed to be one entity to hold the trademarks, but in reality there are two. So it's supposed to be the Postgres Association of Canada, but then there's another entity which is 100% unrelated, which is called Postgres Europe, which also holds trademarks. So it looked like the strategy was to have distributed trademarks. And then we, as a foundation in Spain, which we believe a foundation because of the legal way it's structured, is more solid than an opaque association in Canada, which may be taken, or this one in Europe, that is actually something that could be taken over by rogue actors because of its statutes and how it's structured. We built something that we believed it was more solid and applied for another trademark, and then everybody was unhappy, which is not consistent, because if there's only a single holder for this, which is Canada, which we may agree with that, then Europe, this Postgres Europe,
but look, Alvaro, I know that there's a lot of details in that, but in reality, is it just a provocation? I mean, you don't care. You don't care about the trademark, because if you just want to achieve that someone is listening to other people, so maybe to extra voices. What
the aim was to protect those trademarks. So we realized that some trademarks were not appropriately protected, and we believed that this legal entity could be a very good holder for those trademarks in order to protect them. And especially, some people have criticized this and saying that there was some intent of self-promotion or taking advantage of this, or maybe in the future asking money for this. And that's ridiculous, because the first thing we did with the trademarks is to publish on the webpage, which you can still visit today, that these trademarks are given in the open for anyone to use them freely without restrictions. And actually, they were offered with fewer restrictions than what the Postgres Association of Canada are offering them. So I think actually it's exactly the opposite. And anyway, people complain about this for reasons I disagree with, but it doesn't matter. Some people were upset with this, so we decided in less than 24 hours, so okay, we'll give the trademarks to whom you believe is the best holder for them, and that's an ongoing process. So no, not at all. Actually, what I speak as we, because this is not just me. This is the foundation. I believe that was an incident that shouldn't have handled that way. There was no conflict. It was painted as a conflict and created a conflict, but there was no conflict at all. And it should have induced some change, which didn't happen, and that's a real shame, because it should happen. And we're still in a irregular situation. So all the claim was based that there should be a single entity holding trademarks. There's still another entity which holds trademarks, which is not the main one. And apparently nobody except us complain about that. It doesn't make sense.
Okay. So let me ask you the last question, just in terms of what you are really passionate about this.
Yes.
And then you still see some issues like 20 years old, and maybe you could just jump in and do some development and fix that. But on the other side, look at the market. Like teams of 10 people are making a new database, and they just get billions on a day one. So, I mean, teams can now make a database in a couple of days. So, I mean, Postgres can die. Someone can make a new, just superb database and by default have so many features, which will be really cloud native, really you said a query parser and stuff like that. Maybe they can just be another pod which can communicate to another system and then through some protocol. So why do we care so much? I mean, because the Postgres is not the last database.
So this is probably my favorite question. Postgres could die. Yes, I believe that's the case, and that's why I'm trying to push things a bit further right now, because I believe there is a real huge risk right now. It's not that much related because a new database will come tomorrow and will beat Postgres in terms of features, because I believe database take a lot of time to mature and people to adopt to them. Actually, MongoDB CEO said sometime when MongoDB was around 5 or 6 years old, he said that databases, and quoting Larry Ellison, by the way, the databases take 10 years to mature, which was a little bit surprising that someone running a database which was 6 years old said, but okay, that was very honest, right? So I don't think any database is going to replace Postgres tomorrow, but I see a real risk of people forking Postgres, like a hard fork, Postgres becoming the next open office and everybody moving to the next LibreOffice or MariaDB, if you want to call it that way, and definitely a brain drain. So right now, look at Amazon's Babelfish and the model of Postgres contribution. That's something I'm also trying to see if there's anyone willing to change, and that doesn't appeal. There's a lot of reluctance to change. How do you contribute right now to Postgres? I don't know if you follow the procedure, but for most people listening here. So if you follow the instructions on how to contribute to Postgres, you basically, I'll try to summarize very quickly. First, you need to go to the to-do list, which is a wiki page where all the items are there listed, all messed up from the last 20 years. And you need to find the one that, if there's something similar to this, there's no issue tracker, there's no advanced search capabilities, right? So you need to check this. Then, if you're happy with this and you didn't find anything, then you create your patch and you submit via email. You need to subscribe to a mailing list, which sends around 100 or 200 emails per day. You need to read them or delete them or whatever, but you need to subscribe to this mailing list. Send your patch as an attachment on an email. Okay, then there will be discussion. You'll need to rebase it a lot of times. So send next versions by email. The attachment will be called .1, .2, .3, .4. You're doing version control by hand on the file name. If the patch is very big, you need to split it into pieces. So it will be patch one, version 2 point first part, second part. I don't even know how to. It's already messy. And then if someone says, okay, yes, this is very good, you'll probably do a last rebase, and someone will pick your patch and commit it under your name because there's no pull requests. So some committer who has rights to write to the repository can take your patch, and it will not show up on your GitHub profile because it's someone else wrote on. You'll be mentioned on the commit message if you're lucky. So this is something that is deterring a lot of new contributors to come to Postgres. Now there's Babelfish. Babelfish is this Amazon project that was published a few weeks ago, made open source, and adds a compatibility layer with SQL Server on top of Postgres. This project has been published to GitHub, and very soon we'll accept contributors on GitHub. We'll accept pull requests. Amazon wants to merge this. They call in the right way Babelfish a development branch for Postgres, and they will apply to submit upstream. And I really hope it will get merged with Postgres and will disappear by itself. It will become just a set of extensions. But what happens if that's not the case?
It's not good.
What happens if people start going from Postgres to Babelfish and start submitting pull requests there, and everybody starts being happy there, and there's a brain drain, right? This may happen. So there's things to change to precisely avoid Postgres from dying. You're saying it very well. There's a lot of people with new database companies. They are getting a lot of money, and people are, in some cases, some people that works on Postgres are starting to work on Postgres related projects that they are not Postgres. They're sometimes proprietary, and we're losing a lot of talent. Yeah. So there's significant.
So there is a good example of how things could go work well, like what Java did, like Oracle did with Java. OpenJDK is really successful one. I mean, with all the companies contributing to it, you can now really see what's going on, and the everything changed in Java world since that happened. So it looks so fresh again. So it's not that like there is a company, one company, or but there is a company also contributing a lot to Postgres, but it's not the same position that like Oracle has with Java. Anyway, like making it open and available on GitHub that's how things work in 2021. Okay.
Yeah, but interestingly enough, and this I'll finish with this. This all goes back to the governance and the structure. So in Postgres, there is one team called the core team, and the core team, first of all, doesn't have a lot of attributions. So for example, the core team doesn't even have the attribution to say, oh, let's go and change the contribution model. That needs to be a decision among developers, and developers, they have their own interests, and so first of all, there's a lack of attribution to this core team. But second, this core team, and this is something I've also talked about publicly, is extremely unusual for such an open community with an open source with such a liberal license, is very opaque. So the board meetings are secret, they're not public, they're not published afterwards. The election of members is secret. They chose who they want to elect for the next. The terms are unlimited, so they serve until either they resign or they die. Unfortunately, the latter has not happened, and I don't want that. The criteria for electing new members is also not public, so why they choose this person to be elected as a core member is unknown. And it's not very diverse, which doesn't reflect, and it's not that I'm talking about diversity for diversity, because this is something I don't believe it myself, but it's definitely not reflecting the views of the really multiple Postgres communities around the world, for example, in terms of geography. So there's a lot of improvement, a lot of change that I believe that has to be induced there, and I'm just trying to bring these ideas up front.
Yeah, I mean, I really appreciate that you being so passionate about this. Who cares about the all these establishments and stuff? Just break everything and make a new world and make Postgres better. So that's the only thing we care. And who cares about who is behind and what's going on?
Yeah, it's a difficult message, but I love Postgres and I would like to have a bright future.
Yes.
I don't want Postgres to become open office with all my due respect to open office, of course.
Alvaro, I really want to thank you for this conversation. I mean, we didn't put trash too much on some cloud providers. We didn't say many bad words. We didn't say, but there's a lot of things going on with databases in the cloud, and it's just like a small piece of what's going on. So I mean, everyone just keep track on what Alvaro is doing on Postgres and cloud, and let's see if we can make another meetup like this in a year or two, and have some new stuff that happened in between about the Postgres. Okay.
Thank you for having me.
Thanks, Alvaro. See you in Vegas in a week or something.
Right. Yeah, in 10 days, more or less. Yeah. Great, see you there. Goodbye, everybody. Thank you for.
See you. Bye.
I appreciate it.
Thanks, everybody.
Bye.